and do it separately. So what you can do is you redraw that little your beam, right? And you just apply all the forces that are now no longer in the YZ plane, but the ZX plane. And the ZX plane will look something like, oh, let's see, ZX. X would be, Z would be this direction, and X would be this direction. Something like that. Anyway, so you apply your A force, AX, that's at the end. Just pretend like it's at the end. Then you're going to have this way as 1325, right? And this way, BX. Let's switch this. Let's pretend like we're coming up from the bottom. And this way it'll kind of clean things up. That way, this is going to be going, our AX is going to be going now in a positive X direction. That might tidy up some of the issues here. So, plus 1325 plus B of X and minus 924, right? So this is actually looking from the ground upwards. So almost as if you were looking through a glass plate that this whole thing was standing on. So let's just do it. You have your moment about A once again. I don't know why I always pick A, I just do. So it'll be 100 times 1325 plus 175 times B of X plus 225 times negative 924. And just in case you're forgetting where some of these come from, this one's 100, this distance is 75, and this distance is 50. Okay? So I just keep adding them because I keep getting further and further away from point A. And if you work that out, you'll get B of X to equal 430.86 newtons. Okay. Then you just do your sum of forces in the X direction, which will be A of X plus 1325 plus 430.86 minus 924. And thus your AX will equal 831-ish. Kind of interesting, huh? And this is this will actually come up with your forces. You have your AY, which is what we solved before. Your AY, which equaled 963 newtons, and your AX, which equals 831 newtons. Notice how they're in different components. Let's do BY. BY is equal to 31, 31, and actually we should put a negative there just so we know the directionality of it. And BX, which is going to be 4386 newtons. Okay, so if you wanted to find the magnitude of this force, what you do is you just use Pythagorean theorem. You would do A is equal to this whole thing square rooted, 963 squared plus 831 squared. And I can just work that out for you right now. I hadn't planned on it, but I can do it. 831 squared. That's around 1271.98 newtons. It's more significant figures than we need, but that's the force on just that member, right at point A. What about at B? You could do the same thing. You can tell that this one's going to be much better, or much larger, I should say. 430.86. That's going to be somewhere in the vicinity of 3160.5 ish. Once again, too many figs. But there you go. So this is your total force, total magnitude of the force. And so is this. Kind of interesting how it plays out that way, but yeah, well, you know, I think you guys should really just follow up. We could do some more 3D examples to kind of solidify some of this stuff, because I think it's important that people realize that you can have multiple moments taking an effect in any given situation. So let me see if I can stir something up.